Dobry den!
Ja, Sydney.
Ja, Aaron.
Ja, Olivia. Segondia mi budem govorit u Sheloveshevsky, Skulkovec I Jezykovec Sistemak. Oh, sorry, good afternoon, everyone.
I'm Sydney.
I'm Aaron.
And I'm Olivia, and today we're going to be talking about the human auditory and language systems. So, what just happened there? Well, that first sentence was my weak attempt at speaking Russian. I then repeated that same sentence, but in English. But what was going on in your brain? Did your brain respond similarly to that same sentence spoken in two different languages, despite the fact that you likely only understood it in English? These are the types of questions that inspired the study conducted by Honey and colleagues that we will be looking at today. Their research question was, how similar are the neural responses of listeners who hear the same real-life content, but expressed in two different languages? Let's start with some background info. Language processing is largely lateralized to the left cerebral hemisphere and involves a network of cortical regions spanning the frontal, temporal, and parietal lobes. Two areas which you are likely familiar with are Broca's area, located in the frontal lobe, which is thought to be involved in speech production, and Wernicke's area, located in the temporal lobe, which is thought to be involved in speech comprehension. A dual-stream model of language processing has also been suggested. This model proposes a ventral stream, largely involving the structures in the temporal lobe, which processes speech signals for semantic comprehension, and a dorsal stream involving structures at the parietal-temporal junction and in the frontal lobe, which translates acoustic speech signals into articulatory representations. The auditory system is hierarchically organized. Early sensory areas are responsible for representing low-level physical properties of a stimulus, also known as the form, while higher-order areas are responsible for representing increasingly abstract content. Prior studies have shown substantial overlap in the brain regions involved in processing different languages. For example, when bilinguals are performing grammatical tasks, it has been found that the brain regions involved in grammatical processing are involved at a comparable level when completing the task in L1, their native language, and L2, their second language. In another study, all groups, hearing and deaf, processing their native language, English or ASL, displayed strong and reliable activation within classic language areas of the left hemisphere. So what's missing? Well, the results of these studies do not demonstrate that specific content is processed in the same way in different languages. To examine this, studies in bilingual subjects have mapped neural response adaptation to the same word meanings presented in different languages. Their results suggested that some populations of neurons within language processing regions show language-specific responses, as presenting the translated word resulted in release from adaptation. There's still something missing. These fMRA studies use single-word stimuli, which are unlikely to be processed in the same way as contextually meaningful real-life language. Therefore, it was unknown to what extent the same real-life content elicits similar neural responses across speakers of different languages. That's where this study comes in. In this study, they had native English speakers and native Russian speakers listen to the same narrative told both in English and in Russian. The study had three main objectives. Firstly, to identify brain regions that responded similarly across subjects within a language group when they heard a story in the language they understood. Secondly, to identify sensory areas that responded to the low-level physical properties or form of the stimulus independent of the content it conveyed. And thirdly, to identify brain regions that responded to the content of the narrative regardless of form. What were their hypotheses? Well, when they had participants listen to the narrative in their native language, they expected responses to the story would be reliable, not only in early auditory areas, but also in higher order regions. When they had Anglophones listen to the unintelligible Russian narrative, they expected activity in early auditory areas, but no reliable responses outside these areas. They did not need to specify a priori hypotheses about regions that would respond specifically to content, as they used a voxel-wise approach. This study used intersubject correlation analysis and therefore bypassed the need to specify a prior response model by using one subject's brain response as a model for the response to the same content in other subjects.
In order to test these hypotheses, researchers needed to gather two groups of subjects that speak different languages. They accumulated 9 native Russian-speaking individuals and 9 native English-speaking individuals. In this experiment, they were referred to as Russophones and Anglophones respectively. However, all Russophone subjects could also understand English, but all Anglophone subjects could not understand Russian. To create the stimulus for the experimental design, a narrative story was recorded in Russian by a female Russian speaker. This story was then translated to English and was then narrated by a male English speaker. They ensured that the content of the story was preserved in both language recordings and that the length of the recordings were the same. However, they differed in the low-level qualities, or form, in that it was a male voice versus a female voice, as well as different background noises. The pre-processing for this experiment included 3D motion correction, linear trend removal, slice scan time correction, high-pass filtering, and Gaussian spatial filter to correct misalignment and structural differences between subjects' brains. Additionally, all scans, anatomical and functional, were aligned using Taylor-Rock coordinates. Now it's time for the experiment. First, they got each Russophone and Anglophone participant to listen to the recording of the story in their native language and observe their neural responses. So all Russophone participants listened to the story in Russian, and all Anglophones listened to the story in English. The purpose of this was to get an idea of the brain areas involved in the language network. So what did they find? Well, after averaging the responses of all 9 subjects in each group, they observed reliable responses to the story within early auditory areas, such as the primary auditory cortex and nearby tonotopic areas. They also found reliable responses in linguistic areas, such as superior temporal gyrus, angular gyrus, supramarginal gyrus. You know what? You get the idea. They also found reliable responses in extralinguistic areas, which are thought to be involved in the processing of the narrative and the social content that's within the story. Next, the researchers asked if there are brain regions that will respond specifically to the form of the story, regardless of the content. So instead of the Anglophones listening to the story in their native language, they listened to the Russian recording of the story. Considering the Anglophone subjects make no understanding of the story, it teases out the content, but focuses on the response to the form. As you can see on this slide, they observed reliable bold responses across all Anglophones in only the early auditory cortical areas. This indicated that higher order cortical areas must be involved in the comprehension of the story. Additionally, they wanted to see if this response to the form of the story was comparable across Russophones and Anglophones. They got both Russophones and Anglophones to listen to the Russian story, where they both received the same form, but only the Russophones could understand the content. So when they compared the two groups, any shared activation between them would be a result from only the form of the story. What did they find? Well, activation shared between them was minimal and restricted to the early auditory region, suggesting that it is primarily sensitive to the form or low-level physical properties of the story. Although there were general differences in the physical properties of the Russian and English recordings, some low-level properties were preserved. Considering the time of sentence onsets were matched for both versions of the story, there was a low frequency correlation between the sound envelopes of the English and Russian stimuli. So in order for the researchers to further quantify the effects of form on the responses in early auditory areas, they correlated the brain responses of each language group against the audio envelopes of the English and Russian stories. The main takeaway of this part of the experiment was that the audio envelopes did not predict bold responses outside of early auditory areas in any comparison. Finally, the researchers wanted to observe how the two groups responded to a story with the same content but drastically different forms. To achieve this, they removed the low-level acoustic similarities across the stories by regressing out the English and Russian audio amplitude time courses from all bold signals before comparing the responses across languages. Therefore, all shared brain responses between the two groups would be the result of only the content of the stories. So what did they find? Well, the presentation of the same content with practically no shared form showed a widespread shared response across the two groups. The areas that showed a reliable response across languages included language-related areas such as the superior temporal sulcus, angular gyrus, supramarginal gyrus, and the inferior frontal gyrus, as well as extralinguistic areas including the precuneus, middle frontal gyrus, and orbital frontal cortex. The similarity of the responses across the two language groups was nearly as strong as the similarity of responses within the language groups.
When Anglophones and Russophones listen to the narratives in their own language, the results suggest an emphasis in neural structure dedicated to content interpretation. Response to form is minimally processed unless some aspect of the form is important to content interpretation. Even when the form varied, the overall neural response pathways were relatively similar. The authors suggest that this similarity in high-level processing responses across languages is due to similar syntactic structures. However, English and Russian come from different language families and thus have little to no similarity in syntactic structure at all. A future study could compare languages of the same family, like Dutch and English, and use independent component analysis to investigate whether similar activation still existed or was amplified by similar language structure. When the story was read in Russian to Russophones who understood it and Anglophones who did not, we saw very distinct neural responses. This is because the Russophones were able to process the content presented, but the Anglophones could only process its form. Areas like the precuneus and superior temporal gyrus, which are involved in interpreting and responding to auditory stimulation and language specifically, displayed high activation. This suggests that the human brain places a greater emphasis on content than form. We observe similar responses to content across languages, even with differences in form. Benjamin Lee Whorf hypothesized that structure of a language influences the modes of thought and interpretation of the people who speak it. These findings, however, challenge the Whorfian hypothesis because the same content, presented in different languages and forms, produced similar responses, and the elements of forms did not even pass low-level processing unless they contained behavioral or ecological importance. The author's findings indicate similar neural networks for the interpretation of meaning across the greater population. In addition to improving the study, subsequent studies could investigate language learning communication in musicians versus non-musicians. The precuneus, involved in the multimodal system of reading and interpreting musical instruction, integrating its elements, and effectively producing sounds, may differ between musicians and non-musicians. These same processes are involved in the interpretation of language, understanding the meaning behind intonation, rhythmic structure, and linguistic phonemes. Brain regions in musically practiced people should be adept at performing these same tasks in the context of language translation. By comparing musical and language abilities, we could develop effective learning strategies for improving communication.
Anyways, here's Wonderwall.